Hello learners, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently, I'm a mathematics teacher. Now let us see how to solve this given question. Okay, we have to solve the given system of equations by matrix inversion method. As the name suggests, we have to find out something inverse. Okay, matrix inversion method, right? So first we will construct matrices and then find out inverse and then go on. Fine. I just kept the question at the top so that it will be easy. You can refer whenever you want. Fine. Chalo. The given equations are, see, whenever you are starting your solution for a question, it's always nice to mention the data that is given in the question. So these are the given three equations. Fine. Now you see, these given equations can be written in matrix form. How? Like this. How? See, pretty simple, guys. See, what will happen is see, how I constructed this matrix is the first matrix is coefficients. See, the first equation is 2x minus y plus 3z equal to 9. So what I get is 2, beside y there is minus 1. So minus 1, beside z there is 3. 2 minus 1, 3. And here I have 9. So in the RHS I get 9. Okay, likewise 1 1 1, x plus y plus z means 1 into x plus 1 into y plus 1 into z. That's why 1 1 1 here equal 6 is there here. Next 1 minus 1 z 1, 2 is there, x y z. Now how matrix multiplication works is, like, what exactly will happen is this row into this column will happen when this will happen 2 into x minus 1 into y plus 3z will be equal to 9. So that's when I'll get the first equation. Likewise the second, third row, if you'll multiply, you'll get the second and third equation. Fine. So that's how this system of equations can be written in matrix form. The given system of equations can be written in matrix form like this. Fine. Chalo. Now we take this first matrix as A, the center matrix as capital X, and this matrix as D. So if I'll take it like that, then A into X will be equal to D. A into X equal to D. Fine. This is my matrix equation. Okay. Now, before we apply matrix inversion method, first we have to check whether the determinant of A is equal to 0 or not. We have to check. If determinant of A will be 0, we cannot use matrix inversion method. Okay, so first let us find the determinant of A. Delta is nothing but determinant of A. Okay, det A is nothing but determinant of this matrix. This matrix you see, right? This one's determinant. See guys, this I kept it in square brackets. Okay, now for determinant, there are straight lines like this. You see, there are no edges. Fine, make sure to remember. Now I hope you guys already know how to find determinant. If not, it's fine, I'll explain slowly. So listen, okay. See, I'm going to find out determinant using the first row element. First row, fine. There are three elements, 2, minus 1, 3. Now see guys, listen carefully. In case if you know already how to find the determinant, you can skip this part or increase the video speed to 1.5 or to whatever your wish, but my objective is to help as many as possible. So that's why I'll go into a little basics sometimes. So see how I am expanding. See how this, see, in the first row there are three elements, 2, minus 1, 3. Okay, now 2 into you have to cut off the row and column in which 2 is there. Okay, if you'll do that, what is left out? 1 1 minus 1 1. So I'd get 2 into determinant of 1 1 minus 1 1. Okay, 2 into determinant of 1 1 minus 1 1. Okay, next my second element of first row is minus 1. Okay, now see guys, cut off the row and column in which minus 1 is there. So 1 1 1 1. So that's why 1 1 1 1. You see 1 1 1 1. Okay, but here guys, in the determinant form, like in the method, there is a minus already. So minus is there. This minus is fixed. This minus 1 is our element. Okay, minus 1 into det of this. Again plus 3, the third element, 3 into det of whatever. I'll explain once again, don't worry. Again, strike off the row and column in which 3 is there. This is the row and this is the column. See guys, horizontal are rows, vertical are columns. Okay. Now 1 1 1 minus 1, that of 1 1 1 minus 1. Okay. Now see, once again I am telling how it works is 2 into determinant of this, minus is fixed, this minus is fixed, minus 1 into determinant of the 1 1 1 1 plus 3 into, fine, that's how I get. Now this one's determinant is pretty easy guys, this one's determinant, 2 by 2 determinants, it's pretty easy. So what I get is 1 into 1 minus 1 into 1. So 1 ones are 1, minus of minus 1 into 1 is minus 1. Okay. Likewise, minus of minus 1 is plus 1. Now expand this determinant. 1 into 1 is same. Cross 1 ones are 1, minus 1 into 1 is 1. Okay. See, it's like this into this minus this into this. That's how it goes. Okay. Fine. Now next, plus 3 into 1 into minus 1 is minus 1, minus 1 ones are 1. So minus 1. Okay. Now basic simplification from here. 2 into 1 minus of minus 1 is 1 plus 1, which is nothing but 2. 1 minus 1 is 0 and minus 1 minus 1 is minus 2. Don't make this mistake guys, take it making it as 0. Minus 1 is minus, if you will take common, minus of 1 plus 1, which is minus 2. Okay. Fine. So 2 2s are 4 and 4 plus 0 minus 6. 3 into minus 2 is minus 6. So 4 minus 6 is minus 2. Fine. So delta is not equal to 0. Hence, I can use matrix inversion method. Okay. It is totally okay to use matrix inversion method. Now see guys, in matrix inversion method, listen carefully. In matrix inversion method, first we have to find out something known as a cofactor matrix. And to find out the cofactor matrix, we have to find out the cofactor of each element of our matrix. Fine. This is my matrix. I have to find out cofactor matrix. Okay, for this. Now I need to find out cofactor of 2, minus 1, 3, 1, 1, 1, 1, minus 1. Okay, I'll get 9 cofactors and I'm gonna make a matrix out of that. Now what is this cofactor? Listen carefully. Cofactor of 2 is nothing but, listen carefully guys. This is first row, this is second row, this is third row. This is first column, this is second column, this is third column. Okay, column row 1 2 3, column 1 2 3. Okay, if you will see the position of 2, it is first row, first column. So 1 1, that's why minus 1 power 1 plus 1 I have. Okay, this minus 1 is fixed, power 1 plus 1 because of the position of 2 into determinant of, simple, just close the row and column in which 2 is there, you will get 1 1 minus 1 1. Same as how we did for the that closing part, but this one is something. Okay, fine. Now, so minus 1 power 1 plus 1 is minus 1 power 2 into determinant. I already explained, 1 into 1 minus of minus 1 into 1 is minus 1. So 1 minus of minus 1. Minus 1 to the power even number is going to be positive. So minus 1 power square, minus 1 square is plus 1. So you can ignore that. And 1 plus 1. 1 minus of minus 1 is 1 plus 1, which is nothing but 2. Fine. Now next, cofactor of this minus 1. Cofactor of minus 1. The position of minus 1 is first row, second column. So 1 2, minus 1 power 1 plus 2, that's why. Okay. Into det of, close the row and column in which 1 is there. Same as the previous one. If you do that, what is remaining? 1 1 1 1. So fine. Minus 1 to the power 3 into 1 into 1 is 1, minus 1 into 1 is 1. Minus 1 to the power odd number is minus 1. 3 is an odd number. So minus 1 to the power odd number is minus 1. So minus 1 into 0, which is nothing but 0. Fine. Now third element is this 3. Let me erase these lines. Fine. Chalo. Now cofactor of 3 will be nothing but, see, the position of 3 is first row, third column, 1 3. So minus 1 power 1 plus 3 into det of, again close the row and column in which 3 is there. So you will get 1 1 1 minus 1, det of 1 1 1 minus. So minus 1 power 4 into 1 into minus 1 is minus 1 minus 1 minus 1 into 1 is 1. So minus 1 minus 1. You get right, this into this minus this into this. Minus 1 power even number, so we can ignore that. So minus 1 is minus 2. Again, now cofactor of this. From here on it will be a little tricky, guys. Listen to me carefully. Cofactor of this one is the position of this one is second row first column. So minus 1 power 2 plus 1 into det of. Listen carefully. Cut off the row and column in which this one is there. What is pending? Minus 1 3 minus 1 1 minus 1 3 minus 1 1 det of. Okay, simple calculation. Minus 1 power 3, this minus this, minus 1 into 1 is minus 1, minus of minus 1 into 3 is minus 3. So minus 1 minus of minus 3, minus 1 plus 3, minus 1 to the power odd number is minus 1. Okay, and minus 1 plus 3, so 3 minus 1 is 2, minus 1 into 2 is minus 2. Now the cofactor of this one is done. Now next cofactor of this one is nothing but minus 1 power, its position is second row second column, minus 1 power 2 plus 2 into det of. How to get that? Strike off the row and column in which this one is there. So 2 3 1 1, so minus 1 power 4 into 2 ones are 2 minus 1 3s are 3, so 2 minus 3. Minus 1 power 4 is positive, like minus 1 power even number is 1, so you can ignore that. 2 minus 3 is minus 1. Fine, pretty simple, right? So now let's find, we have to still 4 more cofactors to go. We found out 5. Now I need to find out the cofactor of this. Okay, in the next slide I'll write the matrix A again. You do not have to write because we need it for calculation. I need to find the cofactor of this one. Now cofactor of this one is in second row third column, so minus 1 power 2 plus 3. Strike off the row and column in which this one is there. What I am getting? 2 minus 1 1 minus 1, det of 2 minus 1 1 minus 1. So minus 1 power 2 plus 3 is minus 1 power 5, minus 2 minus of minus 1, so minus 2 minus 1 power 5 is minus 1, and minus 2 minus of minus 1 is plus 1, minus 2 plus 1 is minus 1, so minus 1 into minus 1 is plus 1. Now cofactor of this one, there are so many ones, right? 1 1 1 1. Okay, now come on guys, stay focused. Come on, I expect some focus, guys. I know this could feel a little boring, but when you will do it yourself, you'll find it interesting. Okay, if you listen to me, what this guy is like going so slow, and like, I hope I'm not boring you that much, but you know, like some people need such explanation. I mean, I want to help many, so I'm going a bit slow. Hope you guys understand. Now cofactor of this one's position is third row first column, so 3 1, so minus 1 power 3 plus 1 into det of. Strike off the row and column in which this one is there, so minus 1 3 1 1, det of minus 1 3 1. Wait, I think I made a mistake. Yeah, I made a mistake, I'm sorry. This minus 1 is not there. Okay, this minus 1 is not there. Minus 1 3 1 1, minus 1 3 1 1, so minus 1 into 1 is minus 1 minus 1 3s are 3, so fine. So minus 1 to the power even number, you can ignore it. Minus 1 minus 3 is minus 4. Now cofactor of this minus 1, let me erase this. Cofactor of this minus 1, second row, I'm sorry, this is in third row second column, 3 2, so minus 1 power 3 plus 2, det of 2 3 1 1. Strike off the row and column in which this is there, 2 3 1 1. So fine, minus 1 power 5, 2 into 1 is 2, minus 1 3 are 3, so 2 minus 3. Fine. So minus 1 to the power odd number is minus 1, so minus 1 into 2 minus 3 is minus 1, minus 1 into minus 1 is plus 1. Fine. Now last, guys, come on, last cofactor, come on, last cofactor, this one, cofactor of 1. This one's position is third row, third column. So minus 1 power 3 plus 3. Now strike off the row and column in which it is there. 2 minus 1, 1, 1. Det of 2 minus 1, 1, 1. Okay, so minus 1 power 6, 2 ones are 2 minus of minus 1. So 2 plus 1 is 3. Minus 1 power even number is plus 1, so you can ignore that. 1 into anything will give the same number. So fine. So my cofactor matrix is nothing but, now just write these all like 2 0 minus 2 minus row wise 2 0 minus 2 minus 2 minus 1 1 and minus 4 1 3. 2 0 minus 2 minus 2 minus 1 1 minus 4 1 3 minus 4 1 3 I wrote. So this is my cofactor matrix. Fine. After this I have to find out something known as adjoint. But let's take a short break guys for 1 minute. You see, in life we fail many times. Fail in the sense we do not succeed. It happens, right? It happens with me, it happens to you. You think about something, and so what should we do in such a time? What we have to do whenever we keep failing? I mean, we are not able to achieve. Then we have to be ready to change ourselves, to upgrade ourselves. See, it's okay to make mistakes, but it's not okay to repeat them. Let's say you do a question in a particular way and you did not get the answer. Fine, learn from it and try another method. Don't do the same method again because you know that you will fail. You're getting right. Thomas Alva Edison, he tried so many ways to get the bulb. Okay, he tried one way, it didn't work, went to another way, and he went on. He tried so many ways. So likewise, it's okay to make new mistakes and learn from them and apply again. So keep updating yourselves, guys. It's if you fail, it's fine again. Try again. Try again. The spirit should be there. Okay, we need the spirit to go forward. Now, next, and I know I know Dr. Vivek Indra, he says this a very good word like bounce back. I really like that. Bounce back. If you fail, try again. Bounce back. Like try again. Fine. So now let's come back. So we got our cofactor matrix. Now adjoint is nothing but adjoint A is nothing but transpose of this cofactor matrix. We got this matrix, right? This matrix transpose. Now what is transpose? I hope you know, but if you don't, I'll tell. See, we write columns as rows. Like this column, this is rare, right? This first column, this is column 1. Write it as row 2 minus 2 minus 4. This second column, write it as second row 0 minus 1 1, and the third column write it as third row minus 2 1 3. This is my adjoint A. Fine. Now A inverse is nothing but adjoint A by det A. Okay, it means 1 by det A into adjoint A. Det A we already found out right in the beginning. We got it as minus 2. So 1 by minus 2 into adjoint A is this. Fine. I hope it's clear. Now since Ax equal to D in the beginning, so X will be A inverse into D. You can remember this. X is A inverse into D. Why and what? I don't want to go too much into details. You can just remember this. X is A inverse into D. A inverse we already know. D in the beginning I constructed, right? 962 column matrix. So X is nothing but A inverse into D. Now listen guys how I am multiplying. A inverse is this 1 by minus 2 into this matrix. D is 962. In the beginning I showed. You can refer to the first slide. So fine, 1 by minus 2. Now we have to multiply these two matrices, first matrix and second matrix. Now how to multiply? See, first row into this. So basically 2 into 9. Okay, so basically how it will go is, I'll use some other color, it will look neat. So 2 into 9 plus minus 2 into 6 plus minus 4 into 2. Fine. This into this. Next for the second row, like for the second one, 0 into 9 plus minus 1 into 6 plus 1 into 2. I hope you are understanding. See, if I'll multiply this, okay, I'll tell that later. Minus 2 into 9 plus 1 into 6 plus 3 into 2. See, this one's order is 3 cross 3. This one's order is 3 cross 1. 3 rows, 1 column. So my final output, my final matrix answer will be 3 cross 1. I mean, the order will be 3 cross 1. So this is 3 rows, 1 column. Just simplifying as 1 by minus 2 into this. Now 2 nines are 18, minus 2 into 6 is minus 12, and minus 4 into 2 is minus 8. So 18 minus 12 minus 8. That's what you're going to say. See, 1 by minus 2 into. Fine. And here 0 minus 6 plus 2, and here minus 2 into 9 is minus 18 plus 6 plus 6. 3 2s are 6, right? So now basic simplification, guys. 18 minus 12 is 6, 6 minus 8 is minus 2, and minus 6 plus 2 is minus 4, and 6 plus 6 is 12, minus 18 plus 12 is minus 6. Fine. Now multiply this, now 1 by minus 2 will get multiplied to each term. So 2 in minus 2 into 1 by minus 2 is minus 2 by minus 2. Likewise minus 4 by minus 2 and minus 6 by minus 2. So minus minus cancel, 2 ones are 2, 2 ones are 2, 2 twos are 2 threes are, so 1 2 3. So that's it. X equal to 1, y equal to 2 and z equal to 3 is the solution of the given system of equations. Fine, that's it, guys. Thank you very much for staying with me up till now. Okay, to recap what I just said, like you can remember that, right? Bounce back. Okay, if you fail, it's okay, try again, try again. Okay, have patience and keep trying. Fine, I hope I didn't bore you guys with so much. In case if you felt it was slow, you could have watched it at 1.5 or 1.75 or 2x speed. That option is available in YouTube. And in case you like this video, please hit the like button. It will encourage me to make many more of such videos. And if this is your first time coming across to my channel, please just subscribe to it. Once again, thank you.